Assalamu alaikum dear students. In this lecture we will be discussing the typical techniques of the solving the problem. The first thing is if we are given with the pulley and in this case the pulley is fixed and we have to find out the equation of motion for acceleration and equation of motion for tension. So what we do just in this case equating the clockwise torque and anti-clockwise torque, that in this case our this weight M2 is acting downward and tension is acting upward in this case. So if I make this, in this case this M2G is acting downward and this tension is acting upward. So we will write equation M2G minus T, which will be equal to M2 minus A. And similarly another equation for this M1G minus T, which will be equal to M1 into A. And by solving these equations, just like adding these equations, we will get acceleration is equal to M2 minus M1 over M1 plus M2 into G. This is the case when the pulley is at rest. And if we just because we will have be two equations and two unknowns, so we can solve the part also tension. So tension will be equal to 2 M1 M2 over M1 plus M2 into G. And if this pulley is not fixed and it is moving upward or downward with some acceleration, for example if this pulley is moving with upward acceleration, let's A, so this acceleration will be now in this case G plus A and G plus A, sorry. And if it is this pulley is moving downward with acceleration A, so in this case our acceleration will be not this, but we have to modify it like this, G minus A. So if the pulley is coming downward, we have to write it G minus A, other expression will be remain same. And similarly here we will write G minus A for tension. And another assumption in this case we have done, if in this case mass of the pulley were taken to be 0, and if we consider the mass of the pulley, for example let M, then we have to take into account the mass of the pulley in this fashion. Acceleration will be M2 minus M1 over M1 plus M2 plus M over 2 into G if M, where capital M is the mass of the pulley. Second is if we have this one vertical masses and another is horizontal. So for this case this is M2, so equation of motion for this will be M2G, which is acting downward, minus M minus T, which is acting upward, which will be equal to M2A. And in horizontal case we have no vertical force, so this tension which is equal to M1 into A. So we have two unknowns and two equations, we can solve this. If we add these equations, this will give us acceleration which will be equal to M2G over M1 plus M2. And if we solve for tensions, this will be give us M2 M1 over M1 plus M2 into G. Another case, if we have one blocks on inclined plane like this, M1 is on inclined plane and M2 is in vertical. So we will have equation for this vertical case, M2G, which is acting downward, minus T, which will be equal to M2A. But in this case we have not M2G, but in this case its one component is contributing. So we will write M1G sin theta minus T, which is equal to M1 into A. And again for this case we will be have two equation, tension minus M1G sin theta is equal to MNA for inclined case and M2G minus T is equal to M2A for vertical case. So adding these equation or manipulating we will have expression for acceleration which is equal to M2 minus M1G sin theta over M1 plus M2 into G. if we put for tension, so from is highlighted because I am referring to this equation. So from this equation, if I want to find tension, so I will modify that equation like this. Tension will be equal to m2 into g minus a. So putting values of this acceleration which is highlighted with red color in this a and simplify this equation, so we will left with m2g into 1 minus m2 minus m1 sin theta over m1 plus m2. Now if in another case, if we have both masses attached in an inclined plane, so in this case this m is lying on inclined plane and this 2m is also lying at inclined plane, and this angle may be equal or may not be equal. It does not necessary. So what we will do in this case, we will resolve this and we will take the responsible component for the motion. And as we have done previously, that vertical component is responsible for the motion on inclined plane. So we will write this equation like, if this, because this mass is greater, so our pulley system will move in this direction. So we will write 2m g sin theta minus t, here upward, will be equal to 2m into a, and in this case, because this mass will be moving upward, t minus mg sin theta, which will be equal to m into a. And again, if we solve two equation, this will give us expression for acceleration. In this case, we will like in this, if I modify this expression, for this case acceleration will be m2g sin theta minus m1g sin theta over m1 plus m2, and similarly for tension. Now if we look for another example, motion of a block on a smooth horizontal surface. If we have smooth surface and force is applying on this mass, so just writing F Newton law, F is equal to ma. In this case, force is applying in horizontal direction, so acceleration will be just simply F over m. Now if this force is applied in at some angles, like in this case I have dictated this angle with theta. So in this case, we have to resolve this force into two component, f cos theta and f sin theta. So using head to tail rule convention, in this case f cos theta will be in this direction and f sin theta will be in this direction. As you know, this normal force is always perpendicular to surface and weight is always downward. So if we write equation r plus f sin theta, which is in upward direction, is equal to mg. So r plus f sin theta, which is equal to mg, and in horizontal case f cos theta, which will be equal to m into a. So f cos theta, which is equal to m into a. If we take separate value for acceleration, this will be equal to a equal to f cos theta over m, and here we can find out the normal force, which is represented by r. So r will be equal to mg minus f sin theta. Now another case, here this block is pulled with the help of force F. If this block is pushed by force F at some angle theta with the vertical or maybe with the horizontal, so what will be equation for this? In this case, you are looking that this force is applied and this is pushing this block at an angle theta. So again we will have resolved this, we have to resolve this force into two component, f cos theta and f sin theta. Again normal force is in upward direction, weight is in downward direction, and f sin theta in this case is in downward direction. So r will be equal to mg plus f sin theta, and f cos theta, which is equal to ma. So again we will have expression for acceleration will be equal to f cos theta over m, just like previous, but in this case r will be mg plus f sin theta when we will push this block with force F. Now go for another example. When two bodies in contact, consider two bodies of mass m1 and m2 are placed in contact with each other on a frictionless surface and force, let F force be applied on the block of mass m1. So acceleration of both the block will be, because single force is acting on, so they have will common acceleration which will equal to A is equal to F over m1 plus m2. And if I look for their contact force, so this capital F yani force is applied on m1, and contact force, which is the we will also can say that it is response force, so for m1. So if I take separate it, so F is in this case horizontal direction, and this contact force which is due to m2 response force in back in left direction. So if we write equation for this, F is in horizontal, right on the right hand side, F minus F will be equal to m1 into A. So I have to find the contact forces. So F, capital small f will be equal to capital F minus m1 into A, and we have values for acceleration which will be equal to, like I have highlighted this with the yellow color, which is equal to F over m1 plus m2. So using these values in this expression, this will yield 1 minus m1 over m1 plus m2. We have taken F common because F term containing in the acceleration term. So we will left with F will be equal to m2F over m1 plus m2. Now we have applied this force on m1, but in contact force we have m2. Similarly, same system, but if this force is applied on block of mass m2, so if this force is now applied on this block, so what will be the situation? The situation will be, in this case again acceleration will be F over m1 plus m2, but now this capital applied force yani capital F will be equal to on the left hand side, and this contact force will be the response force on behalf of the m1. So we will just differentiate it. So in this case we write contact force with F prime. So F minus F prime will be equal to m2A. Again we have value of for acceleration which will equal to F over m1 plus m2. If again we find F prime, which is a contact force when applied force is on m2, so F prime will be equal to F into 1 minus m2 over m1 plus m2. And this case when our applied force is on block m2, so F prime will be equal to m1F over m1 plus m2. In this case, you if you notice that when applied force is on m2, in the expression of contact force we have m1 at the top of the fraction, and on the bottom we have m1 plus m2. Similarly, if applied force is on the m1, but in the expression for contact force we have the expression we have the term m2. So we will just rearrange this term if we consider the case for the three bodies. So let's solve it, then we will generalize this result if we solve it for three bodies. When three bodies in contact, so what will be the contact force? Consider three block of mass m1, m2, m3 placed on smooth surface. Let a force F be applied on mass m1 and F be the contact force between m1 and m2. Let F prime be contact force between m2 and m3. F is the contact force between m1 and m2, and F prime is the contact force between m2 and m3. So common acceleration of all the blocks will be equal to F over m1 plus m2 plus m3. This is denoted by equation 1. And if we write now in this case our applied force is acting on m1, and if we just separate the forces and draw the free body diagram for both for the three separate cases. So F prime for m3, F prime which is the contact force because of the m2. So F prime will be equal to m3 into A, and this is denoted by equation 2, and F is the contact force which is between m1 and m2. So F is on the right hand side and F prime is in the is acting in the left hand side. So F minus F prime, which is equal to m2 into A, because we are now considering m2. If you look at this diagram, in this case F prime which is acting on m3, and in this case we have F which is acting on the right hand side on mass m2, and F prime which is the response force or the contact force which is acting on m2 on the right side. So F minus F prime will be equal to m2 into A, and similarly for m1, in this case applied force is capital F in the right direction, and F is which is the response force by m2 on m1. So F minus F will be equal to m1A. So we have just got out our 4 equation 1, 2, 3 and 4. So if we solving one by one from 2 and 1, so if we take this values of acceleration and put into 2, so we will get with F prime which is the contact force between m2 and m3, and similarly manipulating other equations. So this is F prime which is equal to m3F over m1 plus m2. From equation 4 we can rearrange equation 4, which is equal to F is equal to capital F minus m1A. If we put values of acceleration in this expression, we will get small f, which is the contact force between m1 and m2, which will be equal to m2 plus m3 and m1 plus this. Now what will be the equation if we have changed the direction of the applied force? Now this capital F is on m3, so in this case acceleration will be the same, but F prime is in this case which will equal to m1 into A, and response force of this will be equal to F. So this is actually the body diagram. So in this case F1 minus F1 prime will be equal to m2 into A. In this case m1 prime is the response force on mass m2, and consider a free body diagram for m3. In this case our applied force on the right side F minus F1, which is response force due to this m2, and which we can from 2 and 1 if we solve mutually to 1 by 1 equations, so we will left with F1 prime which is equal to m1 F over m1 plus m2. Similarly from 4 and 1, F1 will be equal to F minus m3F, and finally m1 plus m2 and m1 plus m2 plus m3 into sim. So we have to generalize these results what so far we have obtained. Okay, in this case if we look back just for analogy, yes, in this case this F prime was the contact force when we have applied the force on m2. So we have values of m1 at the top of the fraction. Similarly when we applied the force on m2, in this case when we have applied the force on m1, in the expression for contact force we have m2 at the top, and similarly if we have applied this force on m1, and here if I erase this, if we apply this force on m2 in the expression of contact force, we will have left with m1. If we extend this ideas on the 3 bodies, so if we apply force on m1 in the expression for contact force, we will be equal we will have left m2 plus m3 on the top of the fractions like this. If in this case we have our applied force was on m1, but in the expression for contact we have m2 plus m3. Similarly, in this case our applied force is on m3, so in the expression for contact force we will have m1 plus m2 on the top of the fraction in the expression of contact force, just like this. So I have taken an equation in a question. So in this case 3 blocks of mass m1, m2, m3 are lying in contact with each other. In this case our applied force is on m1. So in contact force, in the expression of contact force, we will be m2 plus m3 over m1 plus m2 plus m3. So our this option is correct. So in this case is our applied force is on this. So in the expression for contact we will have m1 plus m2 over m1 plus m3. Similarly, you can generalize this result for all the cases. This is another problem on tension in the string connecting two bodies. In this case, if this force, for example, is acting in this direction and we have to find the tension, so just taking this tension will be acting in this direction, which will be equal to this is m1 and this is m2. So we will write this tension is acting on this object, which is equal to m2 into a. But in this case for m1 we have applied force. This is mistakenly written. In this case this force is actually in this direction, so this F is on the left and this tension is on the right. So F minus T will be equal to m1 into a, and in this case this tension which is equal to m2 into a, because no other forces are acting on this body. If we mutually solve this equation, so we will have left expression for acceleration which is equal to F over m1 plus m2, and if we just put this values of a to back our equation, so we will left with T is equal to m2F over m1 plus m2. And if we generalize this result again, what we see that when our applied force is on m1, so in the expression for tension we have left a term of m2, because our applied force was on m1, and so we have term m2 on in the expression of a tension. Similarly, if our applied force is on m2, so we will have terms m1. In this case our applied force is on m2, so for the expression of tension we can just randomly write that tension will be equal to m1F over m1 over m1 plus m2. Why? Because in this case our applied force was on m2. So if we just make analogies, comparison of equation 3 and 6 give us the following time saving relation. Tension in the string connecting the two bodies will be equal to mass on which force is not directly applied over multiplied by applied force divided by total mass of the system. So we have noticed that here that mass will be contributing on which force is not being applied. So if we look for another equations, a difficult problem of three bodies connected by two strings. In this case we have three bodies connected by different strings. In this case we have common acceleration which will be equal to F over m1 plus m2 plus F over m1 plus m2 plus m3. In this case our applied force is on m3, and here tension between m2 and m3 will be equal to T1, and tension between m2 and m1 will be equal to T2. So T2 in this case on the block m1 only one force is acting which is equal to T2. So T2 will be equal to m1 into a, but in this case if we draw the forces for m2, in this case tension T1 is acting on the right hand side and tension T2 which is acting on the left hand side of this m2. So T1 minus T2 which will equal to m2 into a. And similarly if we write For M3, in this case, what are the forces which are acting? So F is on the right hand side, F minus T1, which will be equal to M3A. Now if we mutually solve this equation, we will left with T2 will be equal to M1F over M1 plus M2, and tension 1 will be equal to M1 plus M2 over M1 plus M2 plus M3. So what we are noticing, just if we find T2, so if I erase this, then I will be able to show you. Yes, T2 is the tension between M2 and M1 when our applied force was on M3. So T2 is equal to M1 into in this case T2 is equal to M1A, because only force was acting on M1. So in this case M1 is contributing. If force is in the horizontal case, if applied force is on M1, so in the expression for tension we will have M1 on the top, M1F over M1 plus M2. So T1 is tension between M2 plus M3. So in this case we have M1 plus M2, which is contributing in the tension 1. So if we have another mass, we can write equation for this. If I consider just like for your, if we connect another block here, which I show like M prime. So if so in this case, if we have to take into account M1 plus M2 and plus M3 prime, so we will also take into account this mass. So look for another questions. In this case, projectile motion on inclined plane. If we have projectile motion on inclined plane, and we have to draw the forces for this motion. So in this case, this angle alpha is just for inclined plane, and theta is angle at which projectile have been projected. So the net angle will be theta minus alpha. Theta, because this theta is total angle and alpha is angle of inclination. So this total angle minus this angle, we will left theta minus alpha. Like in this case, this angle is theta minus alpha, because theta is the total angle and alpha is the angle of inclination. So theta minus alpha is this. If we resolve this velocity into two components, so the horizontal component will be u cos of theta minus alpha, because now we have net angle theta minus alpha for this inclination, and vertical uy will be equal to u sin theta minus alpha. So if this is the value of g at an angle theta, so we have, if we resolve this g into two component, one will be g cos of alpha, another will be g sin of alpha. G sin of alpha will be along the inclined plane, and g cos alpha will be perpendicular to inclined plane. Similarly, we have resolved this velocity into two component and acceleration also in two component. So along the inclined plane, we will have acceleration which will go to g sin theta, and perpendicular to surface we have value of g, which will be contributing component will be g cos of alpha. So these are the some tricks and shortcut which will be very helpful while solving the numerical problem. So I will stop at this point, and in the next lecture I will discuss some problem which we will use these